Alright, on to decomposition. Decomposition is another part of computational thinking skills. So the first was abstraction and the second is decomposition. And again, it comes into chapter 9.1 of our 9618 computer science syllabus. So let's begin with this. What is decomposition? Decomposition is, as its name suggests, breaking down a task into smaller and smaller tasks. So this is pretty self-explanatory. If you have a given task, if you have a given problem, you can usually break that problem down into its little components and sometimes even break those down further. And in the end, you have a lot more components, but they're much more simpler and easier to solve. And that's basically what decomposition is. So let's go with an example. Let's say we had a task and that was to calculate a class average. Now, this is a pretty decent sized task. There's a lot of stuff that goes into it. So for example, to be able to calculate this class average, we would need to get all the marks from the students. So this basically becomes a subtask of calculating a class average. Now, similarly, getting all the marks isn't enough. We need to actually do stuff with it. So let's say we calculate average using those marks. So that is also a subtask of calculating class average. And finally, we also need to output this average that we calculate for it to be actually usable to the user of the program. So for it to be actually useful. And so now, now we basically split this one task that we had into 3 more individual tasks. They're simpler to do, but they're more in quantity. But if you see, calculating average is something that has even more sub-steps. It can even be split further. So when you're calculating the average, you can say that you want to add all the marks together and you want to divide the sum that you get as a result by the number of marks. So that would give you the average. And now you've basically decomposed this subtask into further subtasks, and that is basically the concept of decomposition. And what this leads to, especially in computer science, and you'll study this further in more detail, is it leads to the development of modules. So program modules, it leads to the development of program modules. And what these are is, for example, in this case, divide by total number of marks or add all. These are individual modules, and right now it was a pretty simple problem, so you might say, okay, it's not worth developing like individual functions and procedures for these small tasks, but you could perhaps build much more complex software by combining a lot of these modules. And also it decreases down on development time, because if you have modules, if you have reusable pieces of code that you can implement here and there, then you don't need to keep rewriting those tedious pieces of code. Let's say if you had a module that took a list of numbers and added them and gave you the sum, then you wouldn't need to each time write code that does that. Instead, you could just use that module. So decomposition allows us to develop program modules, and the benefits of these, why you would use them and when you would use them, will be discussed in chapter 12, I think, actually, where we do structured programming. So thank you.